All right. Okay. So, Assalamualaikum. So now we are in the part two of the multiple server. Okay. So what I mentioned in the part one. So the last theory of the basic of the uh, queuing system is the multiple server. In the part one, we have seen the formula of the multiple server, and now we go for the example. So this example, most of the example, where is the where we can see the multiple server, we can see in the post office, we can see in the banks. Okay, we can see for any queuing system that's we collect the number, we collect the number, then we will wait until we will call by the counter. So that's considered as a multiple server. So I just want to repeat for the multiple server. If let's say we have one single line and we have a multiple counter, so that is considered as multiple server. If let's say for the dedicated line, for each server, so this is not the multiple server. This is considered theory 1, 2, or 3. But for the theory of multiple server, one line and we have multiple server. So we have a C, the counter. Let's see this example in the post office. We have a single line here. Okay, this line wait to be served, and for in a we have a three counter, 1, 2, and 3. Okay, we have a three counter, so we will wait until any counter call us. All right, so for example, lambda is the arrival rate per hour. So if let's say lambda is a 10, okay, lambda is a 10, mu is a 4. So mu is a 4. Mu is the number of the customer will be served to be served averagely per hour. Okay. So C is a tree. We have a tree counter. So this is the tree input what we have from this situation. Okay. So what we need to calculate, we can calculate the PO, probability no customer in the system. We can calculate the L, number of the customer waiting in the queuing system. We can calculate W, the time customer need to spend in the queuing system. We can calculate the WQ, number of the time customer need to wait to be served. We can calculate the LQ, number of customer in the waiting line. Okay, and also we can calculate the PW, number of probability waiting. Alright, so we go one by one. So PO, probability no customer in the system. So this is the formula what I mentioned earlier. We have a two entity here. One is sum of, another entity is that just follow the formula. Okay, so we have a C is a 3. So C is a 3. So that's mean the n 3 minus 1 is a 2. Okay, so we start with 0. That's mean we need to calculate sum of n equal to 0, n equal to 1, and n equal to 2. Okay, so for the first entity, sum of 1 over 0 factorial, 0 factorial equal to 1. You can check your calculator. 0 factorial equal to 1. Okay, time 10 over 4 power of 0. Okay, so 1 over 1 factorial. So we go for the next one. It's 1 time 10 over 4 power of 1. All right, so that's why we have n equal to 0, and n is a c minus 1, 3 minus 1 until 2. 1 over 2 factorial time 10 over 4 power of 2. All right, so 1 over 3 factorial time 10 over 4 power of 3, and time 3 over 4, 3 times 4, and over 3 times 4 minus 10. So what we have, the answer is 0.045. You can check with your calculator. 0.045 probability no customer in the system. Okay, so the length, we can insert the numbers into the formula. We have lambda, we have mu, we have c. All right, so The answer is a sick customer in the system. Every time we are monitor the system, we can see the sick in every sick customer in the system. Okay, W is a L over lambda. L is a sick, lambda is a 10, so 0.6 hour. So equivalent to 36 minutes. How I get 36 minutes is a 0.6 times 60 minutes, so 36 minutes. In average, if we go to that post office, that means we need to spend an average about 36 minutes. Okay, so LQ, L minus lambda over mu is 3.5 customer in average in the waiting line. WQ 3.5 over 10, so 0.35 hour or 21 minutes we need to spend in the waiting line, waiting to be called by the customer, by the counter. Okay, and PW is 1 over C factorial time lambda over mu power of C times C time mu C time mu minus lambda power time PO. So 1 over 3 factorial time 10 over 4 power of 3 time 3 time 3 of 3 times 4 over 3 times 4 minus 10 times 0.045, what we get in the PO. So probability that customer must be wait for the Swiss, that means the three counter is a full, is 0.703. Okay, so this is for the multiple server. The situation is same is as a previous one, but the formula is different because we have more than one counter. Okay, so this is the summary. 0.073 probability no customer in the system, 3.0 customer in the waiting line. We need to spend about 80 minutes in average. LQ 0.1 0.5 customer. So this is how we want to summarize the calculation, the analysis of the waiting line of the multiple waiting, not only multiple server, but in all type of the queuing system. So this is the how we want to summarize everything. Okay, so let's see example. Another example, this is your exercise. Because customer for the in the bank, customer arrive in the bank, customer arrive in the bank with the arrival rate is 10 per hour. What is this? This is lambda, because this is the arrival rate, and service time is 10 minutes. So service time is 10 minutes. What is a mu? Mu is a 60 minute over 10, so it's a 6. Okay, and currently the bank have a two bankers, that means two counter. C is a 2. Okay, so we have a lambda is a 10, we have a C is a 2, then we have a mu is a 6. Then we can calculate everything. Probability no customer in the queuing system, PO. We can calculate average number of customer in the queuing line, L. In the queuing system, sorry. So we have average number for the customer in the waiting line, LQ. Okay, we can calculate the average number customer spend in the total queuing average time. Customer waiting for the total queuing system is a W. We can calculate the average number customer spend in the waiting time is a WQ. We have the probability customer is busy. Sorry, we have probability the server is busy. We can see PO. So busy is U equal to 1 minus PO. Okay. Probability no customer in the system. Probability server is either is a I equal to PO. Then we can calculate also for the PW. Okay, probability the customer must be wait before serve in that post office. All right, so thank you very much. So this is the the theory 5 multiple server. See you again. Assalamualaikum warahmatullahi wabarakatuh.